Good afternoon, everyone. Today we're going to continue our lesson on data and data structures. Let's have a quick review of what we have discussed so far. We said that there are several types of data structures. What we're going to discuss uh, are some of the most important ones. So we learned before that a vector is a type of a data structure that contains only one type of data. So you have a vector. Let me just, sorry, let me delete first all the objects here, code C. We have a vector that which contains only one type of data. So for example, let's create this object called, let's call it A1. Okay, A1. And A1 is, let's say, from 1 to 20. So if we create this data, it will appear here in the environment. And it tells us that this is an integer object from 1 up to 20. This is an example of a vector. It can be characters, it can be logical values, can be dates, etc. So that's what a vector is. It's atomic. Now, the second type, the second data structure that we looked at was a list. Okay, could you kindly check if I gave you this code in your file? Okay, I got your message, AJ. Thank you. So do you have this, please? Packet chat. If you have this code chunk. Okay, yes, thank you. All right, so let's have a quick review of this. We said that let's replace this first with C. So we're concatenating these elements here. The elements here are 1, 2, which are numeric, 3 is integer, and then you have this vector of characters, Monday to Friday, and then hello, and then false. So we're concatenating them. Let's see what happens if we create this object called myVector. If I run this, okay, so what happens is that we were able to generate this object. However, there was coercion. It coerced everything into character. Okay, we learned about that. When you create an object containing different types of data, okay, when you create that, it will coerce it into the highest form, highest hierarchy. In this case, it's the character. Okay, so we don't want that. We want an object where we have the numbers, the numerical values 1, 2, integer 3. So it's a combination of data that we want. Okay, and we can only do that if this is a list. Okay, so we said in order to create a list which can accommodate different types of data, then we have to use the list function. List 1, 2, an integer 3, and then you have a vector of strings, character strings, and then you have also this character, and then logical. So if we run this, okay, what happened? You have this now a list. You notice that my vector was replaced by this one. It's a list. It's now a list. And if we click this, it will identify, it will list down the elements of this object, my vector. So it's numerical, integer, character, and logical. It contains 6 elements. You see the okay, later na yung attendance. Okay, so it's now a list, and if it's a list class, it will fall under data. It will not fall under values. Values are reserved for vectors. Okay, and then you notice that a vector can be subsetted. My vector and then dollar, then whatever this object is. Okay, we didn't give a name to this object, but it tells us that you have 1, you have 2, you have 3, and you have the character, etc. All right. So, any questions so far? Before I ask you some questions, a list can, of course, contain a list. Let me share this code with you. Okay, so we're creating an object called L1, right? L1 is a list, and what does L1 contain? It contains my vector, which is a list. Okay, so you have here a list containing a list, and then you have this vector, numeric vector. You have this character, and then you have this logical value. So if you run this, okay, it will print out. L1 is also a vector. So let's see what's inside L1. So you have here L1 contains a list of 6, and then it identifies this list of 6, which is your my vector. And then it also have this numerical 1, 2, 3, and then character, and then this logical false. Okay, so the object L1 is a list of 4. These 4 components include your list of 6 and then your other elements. So I hope that's clear that a list can contain other lists. Okay, so these are the elements. All right, so let's take a look at some functionalities of list. If, for example, we check the class of L1, okay, we know that it will give us the list. Okay, it's a list. And then let's take a look at the structure of L1. The structure of L1 is, you can see here, structure of L1, it's a list of 4. And it contains, the list of 4 contains a list of 6, and then you have this. Remember, the $sign is used to refer whatever object follows this $sign, which is L1. Okay, let me see. All right, thank you. All right, then we can also, let's see what's the length of L1. The length of L1 is the number of elements in that list. So it's 4. Okay, if you check this, L1, so where's L1 here? L1 contains my vector, this object, this vector, my vector, which is a list, this one, hello, another one, third, and false, 4. So that's 4 elements in L1. Okay, let's take a look at how about the names of L1. What are the names that we can find in L1? So nothing. Okay, names are reserved for variable names. Okay, and that's for data frames. And maybe let's take a look at the dimension of L1. The dimension of L1 is also null. Dimension is reserved for matrices or for data frames. All right. So what other things? Okay. So any questions so far, class? May I ask for your feedback as to whether so far our discussion on this is clear? Kindly chat, please. Okay, thank you. Okay, let me wait for the others to give their comments, their feedback. Don't be ashamed to ask questions. Okay, so far we have 11 or 12 giving their feedback. I expect 22 thereabouts. Okay, let's wait for the others to give their feedback. Okay. Okay. So thank you so much for your feedback. Okay, let's continue. Let's just look at other things about lists. Okay, you can a list can also contain a function. Okay, I think you have this. So you have this object my list, and then we're listing a, which is an integer vector, b is a character vector, and c is a function. If you can see here, we have three objects that are included in this object my list, and we impose that this should be a list. If you run this, it will print to us the elements of my list object, and my list can be seen here in our data here. My list of 3, and it contains $A, which means the first object here, $B, which is this one, and $C, which is a function of x, and then x times sine x. Okay. If we check the type of our object, my list, let's run this. Do you have this, class? Kindly chat, please. I'm not sure if I gave you this note. Do you have this, class, in the file that I gave you? Waiting for your feedback. Class, do you have this portion, this object? Okay, I'll assume you have it since nobody's answering. So the object my list contains three things, right? A, B, and C. Okay, A, which is this one, has a different length. So let's see my list, length of my list, and then $A. So that's how we will access $A in the object my list, and we expect the length to be 5. Okay, on the other hand, the length of my list and then $B, okay, this would be 1 because B is just one object, and so with length, now let's see C, it's also one function, so we expect it to be 1. Okay. Therefore, we know that the length of my list itself is 3 because it contains 3 elements, right? And that if we get the dimension, which we did a while ago, of my list, it will be null because dimension is a function that's reserved for, let's say, for data frames. Okay. All right, you can see here my list. You can also get the subset. My list contains 3 elements, right? So you have A, B, C. If you take a look at this one, A, B, C, and then we can subset. We can subset the first element, my list bracket 1. We said that brackets is used for subsetting. Okay, and then it will generate $A. Okay. However, if we try to add 1, okay, let's see if we can add 1 to this my list 1. Okay, it will return an error term. Error in my list plus 1. Non-numeric argument to a binary operator. So it will not run this. Okay. All right. Any questions? Pause for a while again. Questions, please? Or if it's clear, kindly chat yes. Okay. Clear so far. Right? Okay, so let's move on. Okay, we're not going to run this anymore because we have done this, the R norm function and the set.c. Okay, I think that should not have been there. Okay, let's go now to the next type of data structure, which is a data frame. Okay, if we recall, last time we looked at the diamonds data set. That data frame, do you recall where that came from? Do you recall where that data set came from, class? From what package does that come from? Diamonds dataset. A, C, ggplot. Okay, yeah, that's correct. Thank you, John. Kindly share your answer to everyone, please, John. When you answer, please do not just send your answer to me. Please send it to the whole class. Okay, thank you. Thank you, John. You're correct. It's ggplot. And we know, we learned how to install a particular package, but we said that we will not be able to access that package without loading it. So let's load ggplot2 first. What we can do is, there are different ways to load it. You can type library, or you can go to the packages tab here under the files plots window pane. And then if we type, let's say gg, just typing gg will bring us to ggplot2. And you notice that it has not yet been loaded, okay, because this is not checked. If I check this, now what happens? It types here automatically library ggplot. And we know this is the way to load a particular package or require ggplot2. So if we click this, it automatically loads it. Okay, so once we have loaded ggplot2, we can now access data and diamonds. Let's try to review this data set, diamonds. Data diamonds, if we run this, control enter, okay, what happens? You notice it's now here. It's under values promise. So we have to, we really have to load that by, maybe we can use, let's use view. Notice that when I write view for diamonds, it automatically goes here under data. Because diamonds is a data frame, it's not a vector. So let's try to view diamonds. All right. So we have here diamonds, and it brings us to this data frame. You have 10 variables all in all, and then 53,940 observations. If we get the structure of this, structure of diamonds, we'll see that indeed this gives us the data structure of this data set. It tells us that this is all right, it's a table. Okay, and as if you recall, I told you that a table is actually a special type of a data frame. It's a table data frame. Okay, although I think it's a misnomer because a data frame is supposed to be a table. So here it's table df, table data frame, table. Okay, table df. Okay, this is a type of an object S3. And then we have here the structure will give us the data type. caret, that's numerical, cat, that's ordinal factor, okay, which means a factor is a variable that we can use for classification. Ordinal means that it has a rank. Okay, so we have 1, 2, 3, 3 factors here, and the rest are numerical. One is integer. Okay, so that's the structure. And then when we get the the summary, let's see what happens if you get the summary of diamonds. Okay, what it gives us is, let me run that again. Okay. So for the summary of diamonds, it gives us the 5-number or 6-number summary of the numerical variables. So caret is 1, okay? And then we have these 3 factors. If it's a factor, then it will generate a frequency count of the different levels of the ordinal factor. If it was only a character variable, it will just give us the count and then the class and the mode of that variable. Now in this data now we don't have a character. Take a look at the structure. Numerical, factor, integer, but no character. Okay. So let's go back to our data. All right, let me pause for a while. Any questions so far? Questions? Okay, thank you. The rest, class? Waiting for your feedback. Anything you'd like me to repeat? So far, are we clear? Okay, thank you. Thank you for your feedback. Although I'm still not getting 100% feedback from the class. Okay, so what are the characteristics of a data frame? Let's take a look at the diamonds data set. So a data frame has the column name should be non-empty. Okay, let's evaluate our diamonds data set, and let's see if it follows. Okay, let me do this. Let me copy this, the requirements. Let me copy this, Control C. Let me copy it here. Okay, and then let me flash the diamonds. All right, so let's see. Number 1, the column name should be non-empty. Okay, so this is important. In a data frame, the column, it should have column names. Okay, so this we have caret, cat, etc. So all of these column names are identified. Okay, hindi pa pwedeng data frame na may column names na walang pangalan. The row name should be unique. In this case, the row names their names are this one, the index. So 1, 2, 3, 4, 5, up to 53,940. So they are unique. Okay, each row has a unique identifier. So the default is that if you have a data frame, unless you're giving it a specific name for the rows, the default is always an index from 1 up to whatever the number of the length of the data. Okay, and then also the data can be numeric, factor, character, etc. It can take the form of any type of data. Okay, so for this one we have a factor, numeric, you have integer, numeric, numeric, numeric. So all are allowed as far as a data frame is concerned. So this is a combination of numeric, factor, character type. And then lastly, each column should contain the same number of data items. So here it tells us that this is 53,940. If I scroll down, okay, oops, I have to, okay. So these are 53,940 observations. Okay, each column has the same number of observations, which is this one. Each column should contain the same number of observations. And we also checked, we already ran this. Okay, I said that if you get the structure of this object, diamonds, okay, it will give us the data structure, which is table, which is, in a sense, also a data frame. Okay, so that's an example of a data frame. Okay, then let's have our own example. Okay, so we first have example one. I'm not sure if I gave this to you. Okay, let me clear the annotation, clear all drawings, close this. All right, let me share with you this code chunk, unless you might not have it. Okay, kindly copy it and let's study what this includes, what this data frame is. Okay, so first we are creating three objects, N, S, and B. Okay, we're assigning to N this numerical vector. We're assigning to S this character vector A, A, B, B, C, C, and we're assigning to B this logical vector. Okay, so let's run this. Let's run this three, and then we will see that in our values. Okay, so NSB, N is a numerical vector, B is a character vector, B is a logical vector, and S is a character vector. All right, so we have these three elements. Okay, not what we're going to do now is create an object called DF. Okay, to create a data frame out of these vectors, okay, we can create this because they have the same length. Vector N has 3, vector S has 3, and vector B has 3. And we're giving them a name, NSB. So if we create this data frame for NSB, it will create an object called DF containing, which is a data frame. So let's run this. So now you can see that indeed this object called DF here, DF, it's a 3 by 3 object, which means it has 3 rows and 3 columns. So NSB. So if we check the class, class of DF, it will return to us, it's a data frame by virtue of the fact that we run this code data.frame and then concatenate 3 objects there. So the class is data frame. The length, okay, the length is 3. So if we're using the length for a data frame, it will give us the number of variables. And then dimension will be, okay, the size, 3 by 3. It's a 3 by 3 object. Okay, so let me pause for a while. Okay, allow you to catch up. Maybe some of you are still running your codes. Nakamute pala ako. I've been talking for a long time now. I'm mute. Why am I mute? Why was I muted? Okay, I was asking if you were able to run this already. And I was waiting for your response. If you have any questions about this code chunk, about generating a data frame. I was wondering why there were no responses from your end. So, did you hear my question, class? Okay, thank you. Let's wait for the others. Okay. Okay, thank you. Although I'm not getting 100% still. No? Thank you for your response. So clear though. Okay, now let's go to this second example. There are some changes here. Okay, some changes because in the other section we modified this a bit. Okay, so what you have there, you have this, right, class? Do you have this code chunk, example 2? I think the file that I gave you contains this. But we're going to add something here. Again, please, could you kindly confirm if you have this, at least half a partial of it? Waiting for your response again. What you have might not be exactly the same as this. Okay, so for example, you don't have that set.c view. I'm sure what I gave you did not contain set.c, and also some modifications. Okay, but do you have the others? Kindly check your file, please. Waiting for the others to respond, please. Okay, thank you. I hope I'm able to get the response of other students. Usually I get only 6 to 7 active students responding. Okay, I don't know where the others are, what the others are doing. But that's one way for me to know that you're there and that you just didn't come here to have your attendance checked and then you do other things. It's your lost class kasi this is a new skill for you, no? Unless you're already an expert in R. Okay. Why do I have this? Okay. So let's take a look at this class. Yeah, let's take a look at this. So first you have your employee data. You're creating this object called employee data. We're printing it because of the parentheses here. And it's a data.frame. Okay, so we're going to create a data frame, comma, parentheses. So this will be the first vector here, employee underscore ID. And what you have there is, okay, let me delete this. What you have there is this code, run if 10 1999. So let's just first learn what that run if function is all about. Let me just sweep everything here. Question mark run if. Okay, so what will this give us? This function run if. So it comes from the stats package. Okay, and it's all about the run if is used to generate a uniform distribution. So you have here several functions. Okay, and the formula for a uniform distribution is y is equal to 1 minus maximum minus minimum. So this is your uniform distribution function. Okay, and then if we get, let's copy this. Control C, Control B. Okay. So we're generating an object called U. Let me print that. We're generating an object called U. Run if. Okay. Now, of course, we will not get the same values. So the run if function will give us numbers from between 0 and 1. Okay. Of course, you can modify this if you want. For example, numbers between, let's modify that between, let's say, between 0 and 100. Okay. Then it will also generate numbers between 0 and 120 numbers all in all. There. Okay, so it's between 0 and 100. Now, what's the difference between this function run if and what we used before, the R norm? The R norm will generate a random number that's uniform, whose distribution is a standard, whose distribution is a normal distribution. Standard if we don't put the mean and the standard deviation, because the default is 0 and 1. Okay. Now for this one, it's a uniform distribution, the run if function. If you take a look at, of course, we don't have the same values because we haven't set the set.seed. If I check the histogram of U, okay, let's plot the histogram of U. Enter. Okay, let me press this. Okay, so let me run that again. Hist of U. Okay, you can see that. Well, it's not really a uniform distribution because of a very small sample size. So if I access this one, okay, let's change the 20. Let's make it 10,000. So I'm generating 10,000 uniformly distributed numbers between 0 and 100. Let's see this. Okay, I won't print it because that would be too many. Okay, let's just generate that object. All right, so we have that already here in our environment. We have U, just checking U. So that's 10,000 numbers. And then let's now, okay, let's now plot the histogram of U. U is 10,000 numbers. And let's see what will be the difference between the U that we plotted just now and the U that has 10,000 observations. Control Enter. All right, you can now see that this is more, okay, this is more uniformly distributed. And since it's between 0 and 100, the middle of that will be more on 500. So you can see here that this is uniformly distributed. Okay, do you follow? Run if. Let me pause for a while and let me allow you to work on your, maybe it's best for you to write whatever code we're writing. You can put it here in the code chunk so that, because this is temporary memory, what you find in the console. Parang RAM lang siya, no? This will be, this can be deleted or this can disappear after you save it. Okay, I'll give you a few minutes, a few seconds to try to follow. Follow, and if you're done, kindly chat yes to signify to me that I can now move on. I'm waiting for your confirmation that you got it, you were able to run and you understand this run if function. Okay, waiting for the confirmation of others via chat that you were able to run and see what that run if function will generate. Okay, wala pa nag-chat? Waiting for your confirmation, please. Wala pa rin, class. Any questions? I'm not getting any confirmation from your end, class. If you understood that run if function. Hello, class. Are there any questions? Okay, thank you. All right, sige, thank you so much. Okay, so let's now go back to the data frame that we were creating. The example 2. Okay, so let's generate, okay, this one. If we generate a random, this using the run of, it will give us, let's run this, okay, Control C, Control V. If I run this, it will generate 10 uniformly distributed numbers from 1000 to 999. And you can see that it contains decimal places. So let's generate also 10, okay, but this time, let's remove the decimal places and let's just make sure that we have the same numbers. So let's set that seed to 1, 2, 3, 4, okay? And then let's round this off. We can round this off by using the round function and then identifying how many decimal places. So employee ID, we round it off. Okay, so round of this to generate 10 random numbers, uniformly distributed, and let's put 0, which means that there should be no decimal place, 0. And then we press comma. Okay, so we have now this one, comma, and then we go next to the employee name. The employee name consists of, it's a vector of 10 names, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we should have the same number of observations as your employee ID, which is 10. And then also salary, we'd like to generate 10 also. So let's also put here round, then run if 10. And I think I changed this from 20,000 to 50,000, close, and then 2 decimal places. Okay, to accommodate the centavos. All right, and then here we generated, okay, 10. So kindly type this, class. We're including residence is equal to as that factor. So this is how you convert your coerce or impose that a particular character vector be treated as a factor. So this is residence, so this can be treated as a factor because it's different cities, so we can classify the respondents as belonging to different residences. Okay, so I'll give you a few seconds to write that. And once you've written the residence, kindly please chat yes. Waiting for your chat again, class. Okay, I've got one response. Let's wait for the others. Okay, how about the others? Only 3. Let's give them a few more minutes. Okay, thank you. And very good. Okay. Thank you so much, class. Let me check if there's question. Okay, good. All right. So we have created this vector with the name of residence, and we have treated it as a factor. Okay, and then here, let's also start date. Notice that these are actually characters, but we're converting it into data. So as that data, and then these are the dates that they started with the company. All right. Then lastly, we have here strings as factors is equal to false. So what will happen is that if there are any other strings or character variables, it will treat it, it will not treat it as a factor, except of course for this residence, because we have already imposed, we have already coerced this as a factor, this one. All right. So let's first run this one from set.seed. Let's not run the class first. So we're going to run this. Okay, and let's see, it prints because we place the parentheses there. All right, so take a look at our data frame. So the first column is employee ID, the second is employee name, third is salary, 2 decimal places, and then we have the residence and then the start date. Okay, pa-confirm class if you got the same answers. Okay lang kung naiba yung ano nyo, yung residence, it doesn't matter really. But I want you to confirm if you got this 3, 4, 5 columns. Can you chat, please? We should have the same salary. We should have the same ID number, employee ID number, because we use the set.seed. Waiting for your chat, class. I'm asking you if you were able to generate the same data frame. At least for employee ID, employee name, we should have the same. Salary, dapat the same tayo kasi nag-set.seed tayo. Residence might be different. No confirmation, class? Waiting for you to confirm if you were able to run that data frame. Employee data. No? Employee.data, 10 observations of 5 variables. Here. I'm waiting for the response of the others. Isa pa lang yung nagre-respond, no? And lumiliit yung size natin. Kanina 25 tayo. Ngayon, 18 na lang kayo. 19 na lang tayo lahat. Slow rate class. Slow rate yung ano natin, response time. Just one. Okay, sorry Art, may we go back to the code? Okay, let's go back to the code. Okay, this is the code. Okay, I'll give you a few seconds to copy this, to check with your code. Okay, na-generate yung na ba, class? Before we move on. I'm getting only one response. Thank you, Carlos. How about the others, class? O feedback naman, kung may questions kayo dito. Share ko nga muna, class, kasi medyo mabagal yung... Alright, so let's, if we check the class of employee data, we know that this is a data frame. Okay. Then we check the structure. Okay, it's a data frame as expected, 10 observations with 5 variables. And take a look at this. Employee ID is numeric. Employee name is character. Okay. Salary is numeric. And then the residence is factor because we impose this to be a factor as that factor. And then the start date is date. So let's take a look also at the summary. So for the summary, the difference between a character element in your data frame is that here character, it will just give us the count and then the class. If it's on the other hand a factor, it will give us the frequency distribution, the Las Piñas one, etc. So that's the difference between a factor, which we said is used to classify, okay, and then a character, it's just a character, so it will just give us the count and no frequency distribution of that. Okay, and note here the date also gives us the minimum maximum. Okay, and actually this has no meaning kasi hindi naman natin kinukuha yung mid. Well, pwede rin naman maybe in certain instances that we get the median of the date. All right, then we have this example. Okay, for this one, so let's, in case you don't have this, let me just copy it here. Okay, for this one, we're setting that seed to be 1, 2, 3, 4. We're creating an ID from 1 to 200. And then we're creating this group object, which is, okay, so here the rep function is repeat. So it's concatenating, repeat the word vehicle 100 times, and then comma, repeat the word drug 100 times. So this will, in effect, give us 200 observations and create this object called group. So it's a vector containing characters, vehicle, and drug, all in all 200. Okay, and then and then here response is, it's again a normal distribution with mean 25 and standard deviation 5, 100 observations. And then for this one, 100 observations also, mean 23 and standard deviation, which is 5. Okay, and we create this object called response. All right. And then here, we create this object called my data, which is a data frame. Okay. Here we're, what is included in the data frame is the variable patient, which is actually equal to your ID. So ID is a vector of 1 to 200 integers. Okay, so we're giving it a name patient. So actually, we could have just named this patient. No? Para dito, patient na lang, treatment, at saka response. But anyway, this is one way to do it also. And then here, our group, okay, we will rename as treatment. And then our response here, small letter R, we'll rename it as capital R. Okay, so this will now be the column names, patient, treatment, and response. Okay, so we expect to have 200 observations because each of these have 200 observations. Okay, so hindi pa pwedeng yung isa, 100 lang. No? Okay, let's try that. Let's make this as 100, 1 to 100. Tapos si group 200 siya, si response 200. Let's see what will happen if we create a data frame with one vector just having 100. So let's run this. Okay. So nag-run siya, kaso ano nangyari? All right, what happened? Okay, let's try to see muna what now is. Let's see that structure of my data. Okay, structure. So it's a data frame. Okay, I stand corrected, no? Yung kanina, nag-ano siya, nag-coerce siya, no? What did it do? Kasi what we did was, okay, nag-coerce siya. What we did was, ito 1 to 100 lang, no? So ang ginawa niya, since 200 yung iba, umulit siya. Umulit siya, nag 1 to 100 ulit siya. So let's get view here. View my data. Okay, take a look at this. So 1 to 100 yung patient ID. And then after 100, mag-1 to 100. There, nag 1 to 100 ulit, no? Okay? So the row names are still unique kasi ito yung row names siya. No? Ito, this is just a variable, patient. Kaya ang importante dito, although nag 1 to 100 lang tayo, umulit lang siya ng another 1 to 100. Okay, so I hope you get that. So let's return to the original one, 1 to 200, and then let's run this. And then let's take a look at this my data. And let's see if the number is, yeah, tama na, no? 180, 190, hanggang 200. Okay, kasi ginawa na natin 1 to 200. All right. So we have that object. Okay, we know what happens when we okay, get the head of my data. Let's just hide this. So this is the first 6 observations, right? And for the tail, example tail, my data 12. That's the last 12 observations. Okay, and then dimension of my data will be the number of rows and columns, so it's 200 by 3. So that's the dimension. But the length will be just the number of variables, so that will be 3. Okay, the structure we have checked. It's the structure. And then the summary, we have patient, not patient is a numerical variable. So even if ID lang siya, kinuha pa rin niya yung ano, yung di naman natin ginawang factor yan, no? And then treatment, it's a character vector, so count lang. And then response, you get the 6-number summary because this is numerical. Okay. All right, pause muna ako and Again, pause recording muna. Okay, after we have created the object myData, which is a vector, what we're going to learn now is, is subsetting. Okay, so let me share ko nga sa inyo itong, hindi ko pa yata nabigay sa inyo ito, no? Yung subsetting, up to here. I normally would not want to share the code with you because it's best for you to write on your own. But in the interest of time, let me just share the code with you. All right, so let's take a look at this. We're creating this X1 object. But before we go here, this part of the activity looks at subsetting. Okay, so there are different ways to subset your data. Okay, number one is we can use the subset function. So let's run this subset. So there's a function called subset. Let's run that, and it's coming from your base R. Okay, so which means we don't have to load any package in order to access this. So subsetting, it returns the subsets of vectors, matrices, or data frames which meets conditions. All right. So if you have a data frame, if you have we have done this in a vector or in a list. If you have a data frame, you can also subset. Okay. So the default is, right. So this is our function subset. You can have different types here for matrix, for data frame. Okay. This is the default S3 method, and this is the S3 method for data frame. Okay, so we identify the object, the data frame, subset, select, drop. Okay, so those are the possible functions that you can use. Okay, let's have an example here. All right, let's take a look at this air quality, no? Kasi gumamit siya dito as an example ng air quality. Let's check saan ba galing air quality na to. So air quality is, okay, it's also a data frame. It's a data. Okay, it comes from the datasets package, and datasets package is comes preloaded with R. So which means we don't have to install this package kasi naka-preload na yan, no? Okay, then we have here some information about the datasets, air quality. So this is New York air quality measurements, okay, from May to September 1973. And then these are the variables that come with it: ozone, solar, wind, temperature, month, and day. And then may description dito kung ano yung data na yun. And then it says here kung ano yung source, and then references. No? Ito may examples pa ng ng code. Let's try to see. Let's run this. Pero check nyo muna kung nasa packages nyo si graphics. No? Okay, so wala si graphics, di ba? Because sa example, okay, sa help, no? Dapat i-require si graphics, which means dapat i-install muna natin yun. So packages, okay, install. So this is one way. Instead of the install that packages, you have graphics. Okay, there, graphics, install. Right, one or more packages need to be updated. Okay, do you want to restart R prior to install? No, I don't want to restart R. No, but install na lang niya. Okay, so ini-install niya, no? Okay, yan, install na niya, no? Warning, install that package graphics is in use and will not be installed. Okay, hindi siya na-install kasi dapat, okay, again, sorry ha. Ayaw niya i-install kasi dapat i-restart si R. Okay. Skip na muna natin yung class, no? Kasi ang gusto naman natin dito, yung it's not this code chunk, but rather yung subset, yun ang lesson natin. So I just leave you class to try to see kung ano yung lalabas dito sa pairs na to, no? So most probably this is a correlation matrix, yung pairs na to. All right. Okay, so what do you call this? This is data about the data. There's a name for this. Anyone? May data tayo, and then we have this information about the data. There's a name for that. Yes, thank you, Matthew. Matthew, it's correct. It's called metadata. So any information about the data, or data about the data, is called your metadata. So dito, it gives us a lot of information about this data. Okay, so that if you work on this, maybe for whatever statistical analysis, regression, whatever, you understand what you're looking at. Okay. So balikan natin yung ano natin, yung backspace ako dito sa help. So bumalik ako dito sa base, yung sa subset. So let me copy this. Control C. Okay. So you have 3 examples here, no? And I leave you guys to run these examples. So lang ira-run natin. Okay, so we're using the subset function, and we said that it does not need, we don't need to install a particular package because the subset function comes with base R, and then it's pre-installed already. So we're using the object, okay, air quality. So na-access na ba natin si air quality? All right. Before we, okay, let's, okay, will this run? Okay, let's see. Kasi hindi pa natin na-load si air quality. Ano? Okay, let's see if a pre-installed dataset will run when we do a specific operation with it. So run natin to. All right. So what happened? Nag-run siya. No? Kasi pre-installed na yung data. And what we have here is, okay, why don't we give this a name? Sorry. S1, let's create an object S1. Up ko siya, and then S1. Okay, please tell me, class, if I'm going too fast, no? Okay, kinapi lang natin yung code dun sa help ng subsets, and then air quality yung kinuha natin. Yung example niya, air quality, which comes preloaded with R. That's why we didn't need to load it. And then we're creating this object S1, subsetting yung air quality. Dapat daw yung temperature greater than 80, tapos select, the select function will just allow us to select particular columns. So ang isa-select lang yung ozone at saka temperature. The other variables will not be chosen. Okay, let's run this. Okay, so andito siya sa data natin, no? So it's a data frame. There, S1. 68 observations, 2 variables. Let's open this. Yan. So ang sinelect lang niya, select kasi natin C, ozone at saka temperature. And if you check all the temperature, are all those greater than 80. So this is an example of how we subset. And if we take a look at the structure of S1, ano ba si S1? Kasi galing siya kay air quality. Air quality is a data frame. And then we subsetted S1 from air quality with 2 columns, 2 variables. And is this a data frame? Yes, it's a data frame. Okay? It's a data frame. Okay. What if we selected only, what if ang sinelect lang natin is si ano lang, si temp lang, no? So select is equal to, let's say si temp lang. 1, so let's create S2. Yan, S2 class. Subset ni air quality, temp is greater than 80. And then, si S2 lang yung ano natin, ipapasama. And then let's check yung class nito. Class ni S2. Alright, so let's run this. Alright. Okay, so it's still a data frame kahit na, natin isa, no? Kahit na isa lang siya. Yan. Alright. So this is a vector even if we only have one column, because it follows it what's the term for that? It's consistent with the requirements of a data frame. So andyan yung ano natin, andyan yung column that's named, and then we have here your observations. Okay, unique observations, 68 all in all. Okay, again, let me pause for a while because I might be going too fast. Or am I? Sige, any questions? I'll give you a few minutes to catch up. Kita nyo naman dito yung mga codes, no? Isang oras, magto 2:15 na. For X5, okay, nag-X5 ka na. Okay, dali Carlos, X5. Saan na ba si X5? Okay. X5, ito. Wala pang laman kasi ito, no? We have to fill this up. Actually, I was about to ask you to fill this up kasi talagang mag-error dito, no? Kasi wala pang laman. Di ba? Ang subset natin dapat, ang syntax niya dapat andyan si vec, andyan si data, no? Tapos andyan yung mga functions na gagamitin mo dapat in order to subset. Here, ito, class, wala pa to, no? Talagang mag-error pa tayo dito. Okay, thank you for that question, Carlo. Okay, so let's just, it's already, I have 1 more minute. I-run ko lang tong class yung yung X1, X2, mabilis lang to, no? Okay, so subsetting din to. Subset. Okay, so we have here, yung my data natin is what we created a while ago, di ba? Yung may vehicle at saka yung may drug, no? This one, no? All right. So if we subset my data, and then this is the first column and the second row. So instead of using subset, we're using brackets. Kasi pwede rin gamitin si brackets to subset. This means go to my data. So this is my data. And then get the first row and second column. So the first row and the second column is this one, vehicle. Yun lang yun. No? Okay, first row, second column is the word vehicle. If we get the class of X1, okay, here, okay, so anong nangyari dito? Si X1, dapat i-print natin to. Lagyan natin ng print to. No? Okay, print natin. Oops, anong nangyari? Ay, hindi, sorry. Sorry. Dapat dito yung ano. Okay, sorry. Dapat dito yung rows. Okay, run natin to. There. So, ang laman ng X1 class is vehicle. It's a character. Okay, character. Therefore, this is a vector. So, subset nitong isang X1 is a object, it's a character, and sinubset natin si my data. So, pag nag-subset tayo coming from a data frame, it will not necessarily be a data frame also. It can be a vector. So, it depends. No? So, ganun din to, class. So I leave you to take a look at this. Okay. How about this one, X3? X3 is, okay, let me put a parenthesis here. X3 is my data 1 to 20, ibig sabihin the first 20 rows and second and third columns. So we print it and then get the class of X3. Okay, Control Enter, X3. And then dito, alright, print niya si X3. So X3 is, ayun, di ba? First 20. 1 to 20 kasi, no? So first to 20 rows. And then, ano daw? Second and third column. That's X3. X3. And what's the class of X3? It's a data frame. Alright? So depende class kung anong sinasubset natin. Depende. So a subset of a data frame can be a vector or it can be a data frame itself. Alright? Okay, so itong X4 din, ano din yan, no? It's also a vector. It's a data frame. Alright, so X5, what I wanted for you to do was to generate this data frame X4, but using the X5, using the subset function. All right, so we'll continue with this next meeting. Class, it's already time. Let me stop recording. So stop recording.